Alright, got my yard mowed, got me some sunshine, and now I think I'm ready to go back at it. Okay, so what I was thinking about while I was mowing was there's two things that I can do because I'm trying to learn about makefiles anyway. Is basically go from the working state a little bit at a time, just very incrementally until something breaks, and then learn about it, whatever broke. So what I'm going to do, since I don't want to change the default minimal, I'm going to start back over in the Renesas RA folder, delete everything, and then go from a working build. I should just be able to make cross equals 1. And it should work. And then I'm going to take out the cross stuff as the first step. You know what I want to do? I think I want to go ahead and fork this. That way I can commit it. Create a fork. Yes, fork this repository. I plan on contributing to the parent project. Continue. Okay. Go ahead. Well, why doesn't it show the changes? Because I know I have changes. Or do I have to pull it back down? Let's see. Oh, there we go. Right when I was going to close it. I was going to reset it. Okay. Yeah, I want to work at this one stage at a time. That way, if I change something, I can always go back. All right. GitHub's not too happy. Or GitHub desktop. Come on. There we go. Micropython. And it's my Micropython. Alright, maybe we'll close this out. We're going to keep this up over here just so I don't get confused. We got the RA and the RA, so that makes no sense. Let's get the minimal for now. Oh no. Okay. Don't need that anymore. Don't need those. We learned that already. Don't need that. Really don't need that either. Okay. Alright, so is he showing up yet? There we go. Alright, so first thing is we added or duplicated minimal to create RA. Why isn't it showing anything? Oh, I already did it. Alright, so I'll make sure. What about the build directory? Oh, I bet they have it set up to automatically ignore it. Let's check out the get ignore. What am I doing? Let's close all the left for now. Okay. Yeah. Yeah, okay. Cool. Alright, let's go ahead and I didn't oh, there it is. No. Okay. First thing we're going to do is ditch the for one thing, I think I want to use Eclipse as my editor. Even if I can't build in it. Ah, who cares? Alright, so the first thing I want to do is edit the makefile, because this is what I'm here to learn. First I want to edit it to get rid of everything to do with this cross, because it's always going to be cross compiled. So by default, by default, and by default, I don't understand that. Okay, save it, verify, make cross, oh yeah, just make. Let's see if I have a dual core. I can do make J2 probably. Okay, everything's working just fine like that so far.
Hey.
Hey! My wonderful. Yep, it built just fine. Okay. Alright, so commit that. Update makefile to remove requirement to use cross. What is taking so long with this? There we go. Okay. Okay. Now we know we need to change the linker file. So let's compare this with the Renesas linkers. Actually, let's just copy them in and see if it works first. Copy, paste. Alright, and let's find it in here. STM32. Oh, not in here. Oh, whole word. I got whole word only. Okay, there's the linker file. So now we need to do what, fsp.ld? Alright, let's see if it finds the other one. Alright, make clean. Make J2. Oh yeah, much quicker. Or maybe not.
Hey.
I might be able to do J4, I don't know. Okay, cannot find. Interesting. So with Renesas, they automatically include all those. Alright, let's see. See if I can find any mentions of this in any of the make files in the project. Alright, we gotta take this out. Ah, it's just in the linker file. Okay. So then libraries? Library search path? They do have some extra stuff here, so let's see. Let's see what they output for the linker. Where is that? It just says link build firmware.elf. Okay. No standard libraries. Okay. But why? I guess you don't need standard libraries for this. So how would I do that? I would need to update these linker files probably. All right, so maybe I just ditch that. All right, let's see. I want to build a revert, so I want to put in where I want to add the files but not change the make file yet. Come on, is there a refresh? Why does it take so long? Thank you. Alright. Added FSP generated blanket files. That way I can edit them and show the changes. Come on. Maybe I need to push it. Okay, so if we're going to do no standard library, then we probably need to get rid of that mention inside of, it's either this one or the other one. What was it? FSP, okay. Let's see if that works. Vectors. 178. Maybe I have to do a claim. Let's see if J4 works. Oh no, that is defined somewhere else. Yeah. Oh no. They're redefining it. Where's the original? Okay. It's fine now. There's really extra in it. So I need to have system.c at least. Okay. Same thing, okay. So let's do we need, I want to use the directory structure, so we're going to go with, come on now. Put this over here. Okay. Alright, so new folder. RA. New folder. FSP. Source. PSP, Renesas, oops, device, source. All right, copy. Okay, so now how do I update my linker file? So let's see. Let's go system.c. File search all. Surely that's not the only file. What is this anyway? Okay, well, let's see. Let's try first. We need a source, so let's add array PSP source PSP Renesas device access source slash system.c. Okay, let's see if that works. Okay, yep, it's going. Okay, let's get BSP API in there. We'll go through this one file at a time if we have to. Alright, so BSP API. There it is. So it's under FSP include API BSP API.h. Alright, so now we need to add that to the linker file under include plus equals dash I dot slash RA FSP inc API. Alright, let's try that. Okay, we're getting there. All right, FSB Common API. That needs to go in the inc directory. Okay, so now this needs to have the inc directory. Let's try it again. Step by step, one piece at a time. Sometimes that's what you have to do. That way your errors make sense. If you try to do too much at once, sometimes the errors will just throw you for a loop. Okay, FSP version.h now. Same folder, so I don't have to change the include paths. Alright, BSP config. I believe that is in this folder. Nope. Alright, there it is. So we need RA config, FSP config, BSP, BSP config.h, and we gotta add this one to the include path again. Alright, let's see if it finds it. Of course, clock config, that makes sense. Should be right there next to it. No, it is not. Alright, so that's where... no. No. Is it under board, maybe? No. Oh, RAGen. Okay. RAGen. See if it finds it. Okay, that did not find it. Well, that's because I didn't put the file in there. That would explain it. Alright, clock config, there it is. try it again. Sometimes this is the only way to do it. And if not, you'll definitely learn this way. Okay, MCU family config. That one's another one that goes in here. Alright, that's the same folder. Oh, before I make this change, I wonder if I should change it over to Cortex M4. Well, alright, I mean M33. Okay, so now I need to add FSP source PSP MCU R6 and 4 PSP MCU info. Alright, so MCU, let's see. That'd be under RA. No. Okay. Before I do this, I want to switch this. No, I don't. I already started adding a bunch of code paths. Okay, BSP ELC. Alright, so now same folder. I wonder if I needed all these. Because I didn't have to add that one just now. I shouldn't need any more than these. So let's see here. Ink API, yep. That one's in there. That one's in there. Alright, let's try to put them in the same order. Not that it matters, but just because I want to reproduce what Renesas already has. And as I add it, because I want to see if there's anything that breaks it. I want to find anything that can break it. So I should be able to do this and still see the same. Okay. And BSP feature, might as well look for that while I'm waiting. Same folder. Okay. Okay, board config. Way far. All right. So RA config. Already got the folder. Okay, so far so good. Okay, now we're getting into this folder. I believe, let me double check. Yeah. I'm probably gonna add that whole section. I had a feeling. Yeah, I had a feeling I was just gonna have to add all those. Probably just need to throw the C files in there too, but we'll see. Probably give me a bunch of undefined functions and stuff. But I want to figure out where that weird error was coming from, and unless I add it slowly, I won't find it. All right, vector data. All right. Let's see. Where would vector data be? Ah. All right, Jen. Okay. I'm going to end up adding every single one of these files before it'll build. But I might be able to go through it faster here after a little while. Okay. Or I might find the error that was hanging me up before. Just wish it didn't take so long each time. Just looking for file changes, I guess. Okay, so I think I am going to start adding these files in bulk because I know CMSys is all going to be needed. Alright, I don't even have, I'm just going to copy the whole ARM folder. Let's see if that was a bad idea or not. Okay. Maybe that's one of them that has to be. Yeah. And they do it after this one. Okay, let's try it again. Okay, moving along. System.h. System.h. Let's go ahead and add the whole Renesas folder. Let's add the whole MCU all folder. Okay, FSP features. Alright, let's go ahead and add the whole FSP include folder. I'm already getting this R cache undeclared. That was the one I had before. Base addresses. Wonder why it's not finding that. Oh, this. Oh. Okay. So this is probably where I have to change from Cortex M4 to Cortex M33. Alright, so where is... So I really need to be able to make that incremental change first. So let's start off by ditching all that for now. Yeah, and then we need to ditch all that. Oh, how long does it take to... There we go. Alright, verified build. It's going to be building for the STM again. It should just work. I'm going to work on changing the MCU flags first this time. Yeah. Okay. So where's the MCU flags? Here we go. Alright, we're going to rename this to Cortex M33 and this M33. Alright, and now we're going to pull up the MCU flags from here. So we got this one. MCPU. Okay, and then we got mthumb, mthumb, mfloat API equals hard, mfloat, msoftware float. No, we're going to do this hardware. Oh, first of all, let's do one piece at a time to make sure it still works. Because I was having some weird issues with that too. Like it wouldn't find thumb for some reason. Okay. Do I need to do make clean for that? Okay, so that works fine. Alright, let's try going to hardware float. While that's running, I don't know what that is. Floating point unit equals let's try adding it anyway. Oh no. Really? Well, let's try adding that, because that might have something to do with it. F single precision constant. What is that? Is that float related? Let's see. F single precision constant. Really? Not going to search for that? Okay, well, I want to keep it. Just add this here. Maybe you need that extra info. Same error. Alright, well, we're going back to software float then, I guess. Interesting. Don't need that. Keep clicking things. Okay. Message length. Sign chart. I don't reckon any of that is required, so right. I had that working a second ago. JF. Oh, M-Tune still says Cortex M4. Huh. What is M-Tune? Okay, that worked. Wait, did I do clean last time when I changed? Maybe that was the issue. Maybe you just can't change without cleaning. Alright, let's try again. Let's try going to these. Okay, so it did work. Cool. Alright, Mike. Let's see. What else can I add in there from there? I don't know what this is supposed to be for. Let's see if this works correctly. Okay, that works. Alright. Okay. What else can I add now? Let's do these. Function sections and data sections? I don't know what those do. Okay, let's try all four of them. And we'll add it to the existing. Definitely need to do a clean every time you change the makefile. Or it seems like it anyway. At least some of this stuff you have to change. Okay, so that works with the STM linker file.
Hey.
Alright, so we're going to commit this updated makefile to switch C flags from Cortex M4 to settings M default FS project. Of course, I left some of the other options that were already there, but who cares? This single precision constant. Oh, I bet that makes it to where it gets rid of a lot of warnings, I think. That's because we're always like converts double to float implicitly or something. I remember seeing that warning a lot, and I don't have that flag, so that might be it. Now this might actually work, because I'm guessing this gets defined somehow. In fact, let's see where this gets defined. So I'll bet you that's why those aren't being defined properly. A lot of them use it, but I haven't seen anywhere it's defined. There it is. Oh. Alright, so just including this would do it. So this should be getting defined somewhere. That should be getting defined somewhere. Huh. Yeah, I bet you the compiler is defining that. Okay. Alright, now let's switch back over to the other linker file. Add all the paths. I'm just going to do all of them. Because I was just getting that one error before. And if it's just that, then I might have fixed it. Okay. Okay. Of course, I didn't add the C file. Let's see if it has a problem. Probably will. I'll add one C file at a time too. That way we're not building more than we need to get it running. No, I'm not hacking. I'm looking at trying to port Micropython over to a new MCU, one of the MCUs that I'm used to using. But I'm also learning a lot from. I'm usually using the tools that the microcontroller manufacturer gives us, and to get the software ported to Micropython, you kind of have to use their tools to make it compatible with everybody else's stuff. So kind of hacking, I guess, hacking into Micropython to add a new microcontroller. But I think when I'm done, they'll be happy to take it in. Hopefully. Let's see. Let's add. I need to add the directory all the way to that. So that's RA. What was it? That one. Okay, so we got RA, FSP, source, BSP, CMSys, device, Renesas, source, system.c. Alright, let's see if that goes now. Was it system? Let's see. I thought it was system. Interesting. Okay. That does define it. Do I have the right path here? Source, Renesas, device, CMSys, BSP, source, FSP. Alright. Maybe I gotta make it clean again. Or maybe the standard makefile in Renesas brings that in somehow. So let's see. While it's building, let's look at the standard makefile from Renesas here. Ah, all the source participating in the build. Alright, so where are these make files? In here? Yeah. Okay. How are those made? Alright, let's see how this works here. So they actually create other make files. Sources.make. Oh, interesting. Every subdirectory with source files must be described here. Interesting. Okay, well let's try. I should be able to just add this into here. Let's see what that looks like. Okay, and then maybe I can just do this. So I got the one make file. What's objects.make? It's empty, so it doesn't matter. Okay. Let's go ahead and add all these make files that they list here. Dang it. There. Okay. So RA, board, that one. Copy and paste that. Okay, RA, FSP, source. I already did this with BSP, MCU, all. Okay. This might actually be a simpler way to do it. That way I don't have to think about adding them to the existing one. I just include it and be done. Okay. Alright, Jen. No. Okay. And then source. Okay. Now in the main make file, I include all those. I don't see this one. Okay, well, let's try it anyway. See what happens. Wait. I gotta look at how they're doing it. What are these seed depths? Dependencies. Oh wow. Probably need those too. So they're using source C instead of C source. I got an idea. Let's start off with not adding all of them. Okay, let's, because this is some automated thing that they're doing. I don't necessarily need to do it that way because I'm not generating it at build time here. Let's see how these are used. So what are they doing here? Man, I wish I could use these instead. I might need to. I think I need to understand how this works more. Let's, now that I've noticed there's the, let's do something here. Test it. Okay, so let's go with boop, 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 boop. now let's add these in here. Let's add these in here. Okay, so they really break everything out, which honestly it's way more modular. I'm impressed after seeing some of that other. Okay, so that should be all. I should just be able to go in here and hit make, and it should build it. Maybe. All right, let's try this. Multiple target patterns. entry.d1. I don't know. Multiple target patterns. Let's see what that means. Make multiple target patterns. Not helpful. What is it doing different? One thing I noticed was in the make file down in init, there's an arg. Here's a quick question. Is CDT make different? Make files. Ah, that's not gonna work. Hmm. Why is there semicolons afterwards? Missing separator. What is that? Indented with spaces when make expects tabbed. Alright. Oh, they moved on to common data. Okay. I see. Okay. Let's go ahead and open all these up. I might need a way to massage these without having to do all this. Basically, it needs tabs, and then it needs a replace all. Okay, so far so good. All right, kicking ass. I'll keep that. Okay. So now we're in. Did that one. Yep. I'm going to do all files at once if I can do anything about it. Okay. Alright, so first we're going to do anything with a space and all of that we're going to do with tab. Beautiful. Alright, same thing with this. Hmm. Okay. No, not that. Okay, so now we need to do tabs on the remaining. You need to fix any initial. This is kind of repetitive, but I'm definitely committing it if it works. copying it over. No big deal. Only problem is in the future, if I ever have to change anything and it regenerates in the project, I have to massage any new files or manually add it. Definitely not my favorite solution. I'm also noticing some inconsistencies in the way these are generated. So I'm kind of curious where that comes from. How I can reproduce that automation. I need to ask somebody at Renesas, one of my buddies that I just know might know. I just want to see if it can build. This is garbage. I have to do this every time. Obviously it can be automated, but still. Maybe I'm wasting my time with this instead of thinking about how to automate it. How many more do I got? Okay. Okay, let's try it again. See what happens. Board init.d. Alright, well, where's that one at? Okay, missed these. Alright, let's try it again. There we go. Getting closer. Alright, command not found. Count entry.c. Dot source slash. Oh, wait. Alright, let's try something here. Let's see. Source how entry dot. I bet you D. Do we have a line? Line 2, okay. Well, I doubt it's that, but let's just see. Okay, make error 127. File not found. Okay, source howler.c. Oh. I'm gonna have this problem with all of them. Aha. Okay. Yeah, kind of starting to a little bit. This is very tedious. Where's my error here? Permission denied. Okay, well, let's. Different permission, apparently. No, I'm not sure this is the right way to go. Shouldn't have to edit all these that much. I wonder why that's showing red X's. It's building fine. Whatever. I just can't help but wonder why the make files don't just work. There must be some kind of difference in the make files for Eclipse CDT and just make Linux. Alright, we're going to try this now. Oh, that's Windows. Okay, well that's fine, I guess. Okay, let's see, is that it? To build the project in the workspace. This is the one I want to do. Alright, so at the Eclipse execute, no splash, launcher, suppressors. Actually, this is PowerShell. Whoa, what's going on here? No splash, launcher, suppressors, application, org, all that stuff. Data. Okay, we're not going to import. We're going to use clean build my project, which is just that, since it's in the workspace. So this should just work. Oh, probably the build on didn't need to be done, but whatever. We'll see if it works. Sounds like it. Workspace already in use. What? Oh, I gotta close out. Let's try this again. Well, this kind of sucks. You gotta have. Well, who cares? If it works, it works. Okay, so it does work like that. Let's see if anybody's used Make though. Using Make to build an ET Studio project. Creating and executing build CMake project. Yes. Yeah. I don't want to create a handcrafted one. The whole point is to go the other way. Okay, so this is standard for Eclipse. Make file generation. All this information gets added to the make files, and if I do a build, it calls the make utility or builder to make it with all the necessary command lines. I can see what it does. Yeah, this is all new. With this, I should have everything to make a makefile project. Creating a makefile project. Creating a new makefile project in Eclipse with the file makefile project with existing code. Is that the one they use, or the UC project? If I have existing code I want to add, I can use makefile project with existing code. Then I can give a name and an existing code location. I will then create the project inside that code location folder and add all the source files to the project. The generic way is to generate a C or C++ project. Then give the project a name and select an empty makefile project with the supported toolchain. Then press Next and go through the remaining dialogues. Depending on the selected toolchain, creates an empty project. To add something to compile, add a new source file, name its main, whatever. I don't want to create one by hand. Okay. That explains a lot, though. Alright, so from what I'm gathering, yeah, lurkers. There's always get ads from people too. They're like trying to sell followers and stuff. Yeah, so I guess I need to make my own makefile. They have their own makefile already, so I shouldn't have to do that. But that tells me I can't reuse the one in E2 Studio. And that's fine. That would just be convenient. Okay. Get over that for now, Alex. We can go and get rid of the testing directory because I'm not going to be able to not going to be able to use the Renesas makefiles. Wait, that might be up to date. Let's just see where I left off. I can't remember now. Like I can't find vectors or something. Pretzel nugget time. Can't believe it's already 3. Jeez. Time flies when you're like zoned out. Man, it's so pretty outside too. It was nice when I mowed earlier. Okay, so it only fails when it comes to the linking. Maybe I need to just look at how they link it. Compare the linker files first. It's a much simpler linker file compared to Renesas. Alright, let's bring memory regions in.
Hey.
And they don't use vectors, so what do they use? Where is vectors? So where is all these vectors used? Nowhere. So we don't really need to define any of these symbols. So if we get rid of, I've been overthinking it. If we get rid of that, and this, then these can be got rid of, and maybe it'll just build. Because it seems to be just for defining variables that we're not using. I don't think. Don't want to be a know-it-all. Where's UT Studio? Did I close it out? I sure did. Alright. Undefined reference to eData. And a bunch of other things. First, let's see if this is used in code. There's probably a reason why they had that. Just a linker file. Alright, so we can get rid of those. Now, We got two main.c's. We have to fix that. Let's switch to Eesh. This is going to get complicated. So basically, I gotta open up the make file again. We got a main.c here, but then there's a main.c somewhere else. So let's see. So it was defining these variables inside of this probably. Let's see. Yeah. Okay. Alright, we can do this inside of our linker file. So eData is at the bottom of RAM. Data. Is that what it was? Yeah, data. Okay, so we can just do data and instead of eData. Alright, let's do alright. And let's see, what was the next one? SData. Let's see. SData, not going to be in there, it's going to be in here. So SData is at the start of data, okay. Data start, okay. This is getting not too bad here. Alright, let's do data start. Alright. SI data is at the end of text. Okay, so at the end of text, where's text? There's text, so ROM end. Alright. So we'll call this ROM end. See, I got a reset handler already. I don't need all this. Hold on. Let's see here. Let's just reuse it. Okay. Alright. EBSS is at the end. BSS, which makes sense. And BSS, where are we at here? There it is. BSSN. I like Renesas. They're way more explicit. Okay. And the next one is SBSS. Start of BSS. I'm not even gonna. Yeah. Alright, and then eStack. Origin RAM plus length. Let's see where the stack is on this one. Main stack or thread stacks? Let's go with the main stack. So I don't think they did thread stacks on this one. Nope. Okay, so
Hey.
ooh, all these handlers. I just want to copy that straight from the other. Let's think. Yeah, these functions are already defined elsewhere. Oh. And then they're known working too. Let's do that. Let's point these to the right functions here. Alright. No. No. Yes. No. Yes. Okay. So I think I've already included system. Now I need startup because this has reset, default, and main. So default. Got my stack there. Got the vectors. Wait a minute. No wonder it was having problems with the vectors. Alright, let's try something here. Let's undo the deleting of the vectors. Let's add startup.c. We might need to unexclude this one, I'm not sure. We definitely need to get rid of the same duplicate functions though. So we got reset default handler on this one. Let's get rid of this reset handler. So let's undo all changes. We don't need this. We don't need any of that. Where's this used? Okay, we just don't need it, period. And we don't need start because that's part of that function. Okay. Micropy minimum use Cortex MCU. Okay, I see. Where is these defined? Okay, let's just undefine this wherever it's at. Okay. what is that? Menus cortex. Okay, well, let's try it again. Oh, I probably need this. Oh. I'll be right back. Maybe I'm just in time for errors. Yay! Alright, what we got? Undefined reference to NMI handler. Okay, that's fair. That's not a bad error. Let's see. Where is the NMI handler on here? Okay, so I'll need that file added to the make file. So instead of CMSys, we got MCU all USP group RQ.C. Alright, let's continue. Well, actually, since in functions, okay, BSP clock, let's just do one at a time. Thanks. I appreciate it. We'll get it eventually. Alright, so now BSP clocking it. The next one I gotta link in. Well, come on now. Ah, really? There we go. System.c. No, that's where it's called. BSP clocks.c. Next. Okay. RBSP register protect disable. Function calls. Function call. There it is. Alright. BSP register protection. This is one of the reasons I'm like, you got to use the whole FSP with these Renesas ones because they're really advanced, and I want a known working build. Like they do the minimal with the STM32, but like there's not as many people doing the Renesas ones, so maybe you could do something minimal like that, but once you get into actually using the I/O and the peripherals and stuff, it might get more complicated. I'm not sure. Okay, where are we at? Undefined reference to BSP IRQ config. Alright. Makes sense. BSP IRQ. That bug all I needed to do is just add another C file. That's crazy. Okay, BSP init. Board init. That makes sense. I think. Yeah. Of course, it's not actually used for anything, but it could be. Trying to get bare minimum here. Or bare minimum with flexible software package, because that way when I can add the UART stuff that it's going to need. Yes! I have a build. Okay. I got an ELF file, and I got a DFU file. Let's just see if I can program it. So they got this deploy that I can modify, but it's using the DFU, which is, I think, the Python over the UART thing. Yeah. Wait a minute. Okay, so Renesas parts have this same capability with the little boot pin. Let me see if this has the boot pin. But this Python DFU doesn't know how to use it. I would have to make like the Renesas Flash programmer, the command line version. I have to put that in here too. There's the boot mode. I can see it. There's a jumper right here. Well, if I unplug it, you can see it better. It says boot mode, so if I put that jumper over and then plug it up, it allows you to talk over the USB and program it directly without having to have a debugger, external debugger. But I have an ELF file and I have JLink in my system. So the question is can I change this deploy to use JLink somehow instead? We're going to try it. Alright, so this Q, what is Q? Okay, I don't need all the Q's. Um, okay, well, let's use this as a clue, maybe. Nope. Okay, so that's just a Python script. What else is included? Okay, I need to look at that. And this, maybe. I don't know. Okay, let's go. Py make env dot make. Where's q? Ah, q equals blank or at. Oh, so it's okay. So that's not. I don't care. What's the Python? Python 3. Okay, so that's if I'm trying to run Python 3. All right, so let's do, instead of Python, let's comment this out. And let's do I wonder if I have to do that because they're having to. Let's do $Q, whatever that is, and then I want to make my own and call it JLink. I haven't made it yet though. And then DFU. What is DFU? It's a program. Since I'm just running JLink, I need a JLink script. So JLink script. That would be simplest, because then I can just use a known working JLink script. We want a space. Alright, then I don't know what the $@ is afterwards. Maybe that's something specific to. Let me actually Google that one because it has something to do with make. $@ make. Automatic variables. $@. The file name of the target of the rule. If the target is an archive member, then $@ is the name of the archive file. Okay, so it's got the binary here. Then maybe it's this, which I don't need. Okay. And let's see, do I have JLink installed already? No. Let me go ahead and install JLink. Getting exciting. Wow, already up to 7.20. They're always putting out another update. Man, if all it does is Blinky, well, it won't even do Blinky. What is main doing? Because it let me build. And it's going to use this main because I didn't include the other main. Or did I? Oh, wait. No, I just... Where is main in this? I don't think. Yeah. Okay, so it's using this main. What is main doing? Maybe nothing. Or it's running these. Interesting. I wish I could debug it. I have no idea. What's the point of the stack top? Anyway, it's still downloading. Oh, I need to get a JLink file while I'm waiting. Man, do I not have any JLink examples? Let's see if it generates a good one. So build. Debug. It's taking so long. Oh, do I not have it plugged up? Or do? Oh, I had it plugged up to the power port and not the debug port. Alright, come on. Let's do this. There we go. Okay, there's my JLink in my launch file. So I should just be able to use this JLink script. Alright. We'll try it. I haven't used one of these kind before. This one didn't show the programming instructions. I wonder if I have to use this somehow. You know, it wouldn't hurt to know how they use the debugging. JLink connecting to. Okay. Starting server with the following options. And I think that is all what's on here. No? I wish I had one of my examples from work. Let me think. Google Drive. Do I have a Google Drive? I'm going to pull this off screen in case something's confidential. Okay. Yeah, I do have some JLink scripts for a Cortex M33 part, so that'll work perfect. I just gotta log in on my other. There we go. Yep. Sweet. Alright, just go ahead and copy both of these. Download. I know it's off screen though. It's because there's a customer project involved. Which actually they're released, so and it's from the same company, Renesas. I just better safe than sorry, I guess. All right, let's rename this. Oh, program RA604. Okay. Okay, let's say PKRA604. Go ahead and get rid of the confidential. Well, let's see. Is it A? It's AF. Okay, let's save that. We'll call this firmware.hex. Get rid of this extra erase command. Alright, and then this call PKRA6F4.json. Okay, now I can bring it over here. So I got my files. I'll copy them over to this working directory. And I just realized I don't need, well, first of all, let's put these. There's a firmware.bin. Well, let's just do the elf, I guess. Alright, so I'm going to change this to build/firmware.bin. No, elf. And I'm going to make this. I'm just going to test it actually. Okay, system cannot find this path specified. Oh, because my JLink isn't installed yet. Okay, let me close this out so I can bring it back over. Okay. And JLink's small enough, we'll just put it on the C. Wait, did I install it in the wrong location? No. Alright, so now test my little batch file here. And it's programming with the file successfully. Seems to be putting it in the right location. Yeah, 0 through 100K. And then it's erasing QSpy, or yeah, erasing QSpy. That's the 6, this range here, 600, whatever, that's the QSpy. It's an external chip that allows you to read. It's like an extra flash. It takes forever to erase it, but you can read it like it's RAM basically, and so it's good for anything that you need to have that's like a big file, but it's read only. Either way, part of the erase process is to erase all of it, even if you don't use it. I think I'm going to take that erase command out just so I don't do all that. It takes forever. I forgot they had a QSpy on this board. How am I going to test that this is actually running? Well, one thing at a time. We got it building. We're going to have it programming. That's a commit right there. We'll commit that and then worry about getting main updated to actually open the UART, and then if I open the UART, that'll tell me a lot. Excuse me. I wonder what it's using for the UART on the STM board. Because I don't think I can do. I don't know. File is of unknown supported font format. It seemed like it worked though. I don't know if it's working, but let's get rid of the pause. Let's get rid of this. Oh, that was an error. It programmed fine though. Or no, maybe it didn't. Let's get rid of this erase so we can tell better. Because you don't really need that. It'll just erase what you're trying to program. First of all, it's trying to program. Okay, it's erasing that range, but then it programs all of it. Why is it programming QSpy? Erasing QSpy. Do I have something in QSpy on this? Alright, what are we doing? We're using the mylinker file. Does it put something in there? Where am I going? Alright, let's close some of this stuff. Oh wait, did I edit the right file? No, that's why it's erasing it. Close that one. Without any give address. Oh, they did add the address range support in the latest. That's good. I could have kept the original. I may yet. I don't think it has the 2. I think this one has the 1 meg. Let's try it again. Yeah, it's just 0 to F. Okay. Alright, so file is of unknown supported format. I wonder what that means. Well, let's try bin, and then see if that works, because there's a bin in there also. And then I'm going to look at that map file. It's programming. Of course, it's a binary. It's going to program no matter what. The ELF file might be different output format than the ELF that J-Link is used to. Checked out, but I don't know if it's running, but it programmed. So I'm gonna go ahead and commit to this. Added necessary files to get RA startup, and let's see. Oh, let me get rid of all the make files. I don't need to have those in there. That's just going to confuse somebody if I keep them in there. Okay, I can also do this linker file to use RA linker files and startup code. Nice. Yeah, I would love to like play music while I'm streaming, but like there's a lot of rules around that, and it'll just end up getting the whole thing muted. I thought about doing that before. Like I would just love that, being able to stream with music in the background. I could probably go through some things to do that. That's just, I hadn't spent a lot of time thinking about it. Alright, so. No. Yeah, Soma, I haven't used it that much, but I've heard about it. Soma FM. I use Spotify a lot of times. Okay. Gotta make sure it'll still build. I doubt it had anything to do with it. Alright. I guess I don't need all of those Renesas files, but I'm going to put them in there anyway. Alright, so let's do this in steps here. Added FSP linker files. We got that one. Where's the other one? Did I already add that? No, I thought I already added that. Why is it having me add it again? Oh no, it's just showing it changed. Oh, okay. Updated FSP to remove standard library stuff. Okay, and then Updated make file. Oh, you know what I didn't do? I didn't test my. Let's test the make file. Alright, I have to edit it because I didn't actually use the same. So JLink, and I got to find JLink and JLink script. So no, let's not. Let's just say JLink or batch programming script, because that'll just cover it all. Alright, so how do I do that? Let's just do it up here. Equals, what did I call it? Ah, there it is. Program J link DKRA6 times 4.that. Let's just see if that works. Make deploy. Takes forever. No module named USB. Hold on. Oh, I put that in the wrong spot. Let's try this again. Permission denied. Alright, let's try sudo. Super user do. Probably because it's a batch script. Ah, I bet you have to do / somehow. Oh wait, I'm in Linux with this. I gotta make a Linux script for that. Oh, I gotta have a whole another JLink too for Linux. Okay, so that's just not gonna work. Not from Linux. Having it in here will at least show people how it needs to be programmed. So, alright, update make file to switch to point to Renesas linker file. What else did I do? Added includes. Wait, how do I do this? Updated make file. Pointed to Renesas linker file. Added include paths for Renesas startup code. And source files. Updated deploy to show example of using programming script uses batch file to call JLink on a Windows system. Program binary from build directory. Okay. So that's that. Alright, what else did I change here? Updated npconfig port to disable default init code. Alright. Added. I can do this in several commits instead of doing this all at once here. Alright, let's do that. That's right. That's how engineering is too. There's a lot of failures on the road to success. But through those failures, you learn a lot. They're not really failures so much as just like the next thing. Like, you know, the whole thing with engineering is you're doing something that hasn't been done, right? So there's no failing really. It's just you haven't done it yet. Yeah, exactly. Learning, always learning. If there wasn't something to learn, anybody could do it. That's why you have to be one of them type of people that just keeps wanting to figure out something new to be able to do this kind of work. Curious minds. You can step back and ask yourself, what's the point of all this every now and then, and it's like, maybe there's not. It'll help somebody else, and it's teaching me something, so it works out. I don't even care about Micropython, but a lot of people in the hobby world are using it for all kinds of stuff because they're afraid of using C programming. But I actually know C programming, so I can help them have the easier programming language. Added programming scripts for use with JLink. Sure is slow committing. There we go. All right. Pretzel time. Pretzely and peanut buttery. There we go. Push that up to my GitHub. Okay, so I'm building Micropy minimum. Let's see what I need to add next. First, I'd like to see it blink. So what I think I'm going to do, instead of using main, I'm going to go ahead and put their startup code into my HAL entry. Because see, you can't actually edit main on these projects, but they give you this HAL entry file to add your own code here. So what I'm going to do is take their main code, alright, they have all this, we'll put it in, first of all, close all, no, we don't need this, we don't need that, we don't need that, excuse me. Micropy enabled GC, is that? It's enabled, so what's GC, I wonder? GC collect. This GC collect implementation doesn't try to get root pointers from CPU registers, and thus may function incorrectly. We might have to figure out how to disable that, but for now I'm gonna. So they create their own heap. It's just a variable though, so whatever. Oh, well that means that will probably need to be in there too. Alright, so source HAL entry. Let's add it right here. Alright, and then any variables that are needed. Probably need all of this. And HAL data. Alright, and then Micropy enable compiler. Is that used? Yes. Okay, so we need this. Gonna need all that. And I might as well just copy all of this. No. That. Down here. Okay, and then I've already disabled those, so that can just go away. Alright, so what I should be able to do now is go back into my make file and get rid of this and replace it with HAL entry. So be Renesas art source HAL entry. Which will provide its own issues probably and require me to add some more stuff, but let's just see what happens. Oh. Come on. You can do it. Okay. Undefine reference to main. Alright, so now I need the main. Where is main? RAGen main.c. Okay. RAGen main.c. I don't guess the order of that matters. I don't have to do sudo every time, I guess. Yes, you are. You're like a. You're hyping me up over here. That way I can stay motivated. So this pin config variable is in pin-data.c. All right. I hear music in my head. All right. Common data.c. Wait. RHM common data.c. All right. One file at a time. Takes a little while, but makes it easier for debugging. Especially when you're as clueless as me. Like I can write software, but I'm not trained in it whatsoever. I didn't even go to school for that. I've just learned it as I go. It's like a magical world of magic where it's all just magically works. Okay, so FSP source RIO port. I think that's how it is. Let's see. Yep. Okay. Okay. In function undefined reference to Alright, so now I need that whole file path. Let's bring him over here. And you over there. There we go, much better. So RAFFP source BSP MCU all. Okay, let's do BSPIO.c. Probably could just add all the C files to this and be done, but I'm tempted to actually, because I know I'm going to need them. Yeah, I think I'm going to, now that things are building smoothly. Well, okay, so apparently it built already. I didn't need anything else. Okay, okay, cool, cool, cool. Nice. Now let's add Blinky. Actually, let's get rid of that main file that I don't need anymore. Nope, wrong one. Got everything in Howling Tree, so delete that. Come on. Alright, moved code from example main.c to Renesas. Now let's just say RA FSP generated entry.c. So okay, one step further. Alright, next, let's put a blinky in there. That way we can see that this is actually building right. Well, it's not just Twitch, so I'm streaming to YouTube, Twitch, and Facebook simultaneously. And I probably could get away with it, but it's okay. It's distracting sometimes. I might experiment with that sometime, but I'm not thinking of it right now. Let's see. Okay, so I think I made, yeah, so there's some blinky code in here. Okay. Oh, wait a minute. Oh, duh. Yeah, it's not in this project. Okay, so I need to go here. Okay, so it should be configuring the pins now that I'm using my main, or it might have been doing that before. So this is a for loop. Yeah, there is no non-secure code. Okay. Might do this just for temporary testing because I don't really need a blinky, but I do want to. Oh, that's also thread. I don't want to do threads. Let's just copy this whole thing. Actually, let's do it. Apparently, that's not actually copying. There we go. All right, so just for temporary, we're going to just going to go straight into blinky loop and never come out. We can't do sleep though. Let's do gotta remember what the function is. Software delay. So the idea is to blink once per second. So 1 ESP delay units seconds. Alright, so that's what I need. Okay. That should just blink away. Let's build it and see if it blinks. Just as a test that this is actually building right. Yeah, that's a good idea. You'd be surprised, I don't listen to music at work even, hardly. I just listen to silence most of the day. GBSP LEDs undeclared. Oh, okay. That's what I'm missing. Let's just do it with this because I'm going to get rid of it all later. Of course, that might require another file to be added, so we'll see. Yeah. All right, so oh wait, not an examples project. All right, board LEDs.c. Okay. Okay, the BSP software delay is another function that I haven't used yet. Let's see where that's declared. BSP delay. Well, that makes sense. Okay. Might as well do it in alphabetical order. I'll fix more later. This is getting exciting because I'm getting more familiar with the code now that I'm just into the Renesas stuff. So, yeah. I don't even know how Micropython works, but supposedly that built. You're supposed to be able to like upload a Python file to it, and somehow I might just be able to build in Python files. All right, so program JLink. Yeah, boy. That tells me everything's building correctly. Okay, well, alright, what's next? This is really not taking that long. I'm surprised. I mean, overall. Alright, let's commit this change. I'm over to the bathroom waiting for GitHub to wake up and find my changes. Well, actually, I don't want Blinky in there. So I'm not going to add these changes. That just tells me it's working right. Okay, so revert both of those. Okay, so now that I know it's working right, how do I test the Micropython part? There's this frozen test.py. And also, one thing I haven't updated yet that I probably need to is this stuff down here. No, there's nothing. Wait a minute. So in the original, I deleted it already. That's why I don't see it. In the minimal, there was some defines down here. There's a STM32 in it, and all these peripherals. Oh, okay. That's just setup code. I have all that. Okay. Sweet. All right. So how does MicroPython work? Never used it. README. Maybe that'll help. The port intended to be microprocessor actually runs. It can run under Linux. And on any STM. Okay, this is not true in my case, but I need to update this text. This version of the build will work out of the box on a POD and will give you a MicroPython REPL on UART1 at 9600 baud. How? Oh boy, I wonder if there's something that they build that's specific for STM32 built into the Python stuff that I've included up in here. REPL. That's what it's saying. Because how does it know what UART to use on a Renesas part? It obviously doesn't. And pin PA13 will also be driven high. This turns on the red LED, obviously. Not in my case. Oh, wait. I bet you that initial setup code is also setting up a UART and handing it over to somehow. Okay. Okay, so what do we got? Turn on LED. Okay, we don't care about that. Enable UART1. Okay. So I gotta reproduce this in Synergy, or FSP, which I know how to do. But how is it using it? They don't give any functions for another thing to use. Gotta find out what this REPL is. Micropython. Read, evaluate, print loop, and it's the name given to interactive Micropython prompt that you can access on. Okay, we don't care about that. Yeah, so I should be able to get like an interactive prompt. So now I need to look at their REPL code and see if they like have it a certain way set up for STM32. Ah, okay. Receive car, process car. Okay. I don't know how that was working. How does that build? MP HAL, standard in, RX car. Where is that function? It's a HAL function, so MP HAL port. Okay, this one I have to. Ah, okay. This is just an empty function. That's why it works. Okay, well, it's cool. I can implement this. After I fix the braces. MP HAL ticks milliseconds, huh? I need to know the time. Okay. Okay. Set interrupt care. Well, there's other functions here. Standard in, receive car. Is there other ones? UART core. Oh, that might be it. Duh. Okay. There we go. So it was doing something with that memory address, whether it meant to or not. Oh no, I got rid of all that. So that goes away. I think menu standard out goes away too. Let's see. Yeah, I found where the UART stuff is. So I didn't understand why it was working, why I was building okay without it, but I figured it out now. Where's that mphow config? If defined Linux, which is not, so I'm just going to zero it out. Alright, so these are the functions I have to override for reading and writing. So basically the way Python works is like this. So I say Python, I run Python from Windows, and I get this prompt. And I can do stuff like, well, I think I have to do, and it does stuff. So it's like an interactive programming language. And that's what the idea is. You can do that over into an embedded device. So with this, it might just start working like that, which would be pretty cool. That would be a really good start, in my opinion. Okay, so we're not using standard out. We're not using that one. So I just need to reference this code as an example. And then, okay. Send string of the given length. Receive single character. So let's see. Okay. Let's go back into minimal. Figure out which UART I want to use. I have one of those cables, so that's good. I wonder if it gives me a UART. There's one, TX01. I wonder which one that is. I need to pull up the board schematics for this. Okay, EKRA6M4 schematic. Come on, Renesas, be useful. There we go. Maybe this will be good enough. There we go. Oh, that's PMod. I don't want to use PMod. Yeah, let's just use the Arduino connector. Okay. There it is. That's what I needed. SCI 7. All right. Driver. UART driver. UART driver. Okay. Channel 7. Let's go ahead and enable it if it's not already. It is. Okay, good. Alright, what did baud rate did it say? I guess it didn't matter. Let's crank it up. I'm just going to use the default. Shouldn't need anything else. Need to create this. I'm trying to think. So mine's interrupt driven, and they're doing it like they're not sleeping at all. If I did this with an RTOS, I could sleep. No, there's another way to do it. I'm so used to doing it with RTOS that I forget how to do it without it. Event driven. Oh, is the stuff even enabled? Enable compiler. Yeah, okay. Event driven. Where's the event driven? Do my eyes look funny or something? Hmm. Else. Yeah, totally. Totally deep in thought. PyExec friendly REPL. I wish I knew which one of these it's going to. Oh, I can search for it here. Well, let's see if it shows up in this one, because I feel like they would use event-driven, but I don't know. Nope. Okay. Let's see. What? Close search. Thank you. Let's see where this is defined, if anywhere. Hmm. mpstate.h, huh? While that's continuing to search. No. Dang it. Okay, it's just another place that uses it. Okay. ipconfig ports. Are you going to show me the path? Okay, there's the minimal. Not many people doing the event driven. Hmm. Okay, well, we can do it this way. So, but instead of instead of accessing the register, I have to do it differently because the way Synergy FSP works. So we've generated that. We need to take the code and bring it now. Give this a second so I can see what all changed. Make sure I didn't screw nothing up. Let's verify this build before I bother. Excuse me. Yeah. Okay. All right. So here's the new. All right. Added UART using FSP configurator. That's all the UART stuff. How did that all get deleted? Oh, yeah, I don't need to copy that part over. Oh, I could barely tell what that face was about. It looked like cross-eyed. It's really small. Yeah, once I got close enough, I could see the little lines, but it was really hard. Couldn't tell. I bet my mines are out of power.
Hey.
Okay, that built great. Alright, so now let's start updating this. Oh wait, let's commit that first. Cleaned up our code. Oh, crap. Adding FSP UART code. Congratulations, I've received 100 messages today with Restream Chat. No mind power. Alright, so that's committed now. Alright. More data. Oh. You like that little trick there? Find fast ways to do things after a while. Alright, we don't have an RTOS, so we're just doing a flag system, I guess. I really don't want to do just like that because I know I'm going to have errors. I could make it a little circular buffer. I really don't feel like it though. I want to just use like a cube. Tempted to turn this into an RTOS project. I don't think it would be any harder. I've already gotten all the hard work done. Well, for now, let's just do it this way. Yeah, I don't need all of that. Let's see, what are they using? There's the string and the length. Okay, so I just do string. It gives me a pointer already. And length. And it's saying const char, so I need to 8. Get rid of warnings. Might as well convert that to get rid of warnings. Alright. Yeah. There's no way to send an error back, so so let's just do this. Alright, we're going to need to include how data.h. Alright, and now read. We're not going to do read here. Excuse me. So we're basically going to wait forever. G X data. I think that's what I called it. Yep. Equals false. Then return C equals. Oh no, I can't do it that way, but close enough. Alright, so now I need to write that one. UART 0.read. Oh wait. Okay, now I have to do it that way. Is C a pointer already? No. So at C 1. Because it's just going to be 1 byte, yeah. It's very similar to the Linux version, except instead of the control structure, they have like a file number that they use. Okay, so we need this. Well, I guess I don't need to do that. Okay. It'll automatically wait. Okay, simple, nice, beautiful, clean code. Alright. Now, unfortunately, I still have to define this. I just don't need that variable after all. You can just miss bytes. In that case, I don't need any of this either. Okay. Yeah, I don't know what that's about. I think I can get some kind of ticks. How would I do that? I'm not sure what this. Let me look that up. NP help. Of course, I could just look at the other example. Yeah, let's look at the other example. It doesn't even have the same ones. Oh, I'm looking at the header file. Okay, let's see what's in their header file.
Well, I guess we don't really need that. It wasn't in the default initialization. Alright, I need to copy my UART code here. This can go away. This needs to be copied into my initialization. So that's going to be in here. Okay, so we need to initialize UART. Okay, that should work. Of course, I'll probably have to add some more files to my linker. I might as well get my UART cable ready. Speaking of which, where is that? Oh, it's FSP, yeah. I love how it offers suggestions when you get something wrong. Yeah, boy. Now let's try again. Where's my UART cable? Oh, here we go. Let's see. Female to female, so I need a male to male. So I don't need all that. Let's keep some of that. Take. Okay, undefined reference to G UART 0. That makes sense. Alright. In function. Okay. So what I need to do is add the file where this is defined, which is haldata.c. Do I not have that yet? No, I don't. Okay. Alright. Jump wires, jump wires. Here's some. Mail to mail. Sweet. Okay. Good old USB to UART cable. Okay. Another error. GUART on SCI. Would make sense. I gotta have the actual driver code in there. Okay, so RA FSP source. We'll add it right under our IO port. All right. ground. And then let's just make these match. Doesn't matter. Is there something? There's something broke off inside there? Oh no, there's some solder on the end of my wire keeping it from going in. Alright, we're going to switch to the red wire. Okay, that one fits. Alright, so we need ground. Where's ground? Ground is my brown. I got red and yellow, so we'll get rid of the orange for now. We're either going to have it reversed or correct for the first time. That's usually how it goes. There's my ground. TX and RX, you can swap them without breaking anything. Okay, no such file or directory. Did I forget it? RA, FSP, source. Oh, I got the .c twice. Alright, so let's go ahead and get TerraTerm ready. COM1. Oh, I don't have it plugged in. Okay. COM4. We picked this baud rate. Alright. Now hopefully something will just happen right here once. Oh, it's built. Sweet. Okay. Programming time. Alright, let's swap these around. Reset. Ah! Okay, so did you see that? I got a little arrow. On reset, I got a little arrow. Yeah. Okay, so one of my functions is working correctly. The right function. So I have my prompt. Okay. All right. It's starting to pay off here. All right. So just as expected, my read is going to be a pain in my butt. Wait. We need to figure out how this works. So what I want to do is I'm going to make this example project just read in a loop. Wait, why am I doing this? I got the code ready. Okay. Alright, so every time it finishes, or the first time it gets a character, it should hit that breakpoint. If it gets it constantly, then that's going to cause a problem probably. If it doesn't get it at all, that will also cause a problem. So at least I'll know what the problem is. Okay, yeah, it does hit it right away. What's the error? I need to add FSP error type FSP error equals FSP success. And now let's do FSP error equals. Because what I'm thinking is if it gives some kind of error code back, then I can just wait for the error to be success, and then that'll work maybe. Optimize that. Okay, well let's see. Turn off optimization so I can even see what the value is. It got optimized out because I'm not actually using it for something, which is cool if you want to save code size and stuff. See right there, the warning tells you it's going to be optimized out. Set but not used. Unused but set variable. Says success. Ah, that sucks. What is it showing in character? 0? Alright, so what I need to do, let's try the other way I was thinking about. Alright, so if I remember correctly, G Rx char equals true. Alright, oh, Rx data, how about that? No, let's just say char. So while, let's do while grx char, while not g, so just anytime it's false, it'll just, no, I just want it to wait. Once that goes true, that will break out of there, and then we'll set this back false and read the character. I'm thinking that's how I gotta do it. But we might drop bytes, I might have to slow it down. What does that face mean? Okay, that waited at least. Let's see if I get a new line. 0? Oh. Oh yeah, that's right. It doesn't break out. Let's do something different. Let's get rid of this breakpoint. So read, if I remember correctly, doesn't work for that. So let's do it this way.
grxchar equals pargs dot data. And we're going to change this to a unit 32. And now what we're going to do is I still need a boolean. Okay, I want to set the value before I set this equal to true. And then when I get it, I want to set it equal to false. And the read is pointless, so I'm just going to get rid of this. And what do I want to do? I want to do something there I can breakpoint on. Let's just do this again. Okay. Yeah, this goes with how I had to do it before. It can override it midstream, but who cares? That's just how you drop bytes. I'm going to end up dropping bytes probably at this speed. Then again, that's the only thing it's doing. I guess it depends on how long it takes to parse it. Alright, so it should just wait. Why? Oh, I don't want my breakpoint there. Okay, so nothing's available. I should be able to do this, get my breakpoint, and see what char is. New line. Okay. So that's simple enough. Let's do this. Let's do that. Let's do this. Okay. And now instead of reading, we're going to implement this. Just those two. And to make sure we're not using the same exact variable, I'm going to say return C equals, actually just return. So we don't need this. And we're going to make this volatile because it's getting operated on by a interrupt service routine, which is standard practice to do. Okay, that should work. We might actually have ourselves a UART. Hey, man, I don't even know what all commands you can do. I guess I need to look that up. Micropython. Oh yeah, none of these other features are going to work. But I want to know what the basic language is. Not that kind of language. Yeah, me too. Super hyped. I should be able to hit enter and get a new prompt at least. It's a single character. Should be able to read that, no problem.
Let's reset it. I don't have any thoughts yet. I'm still thinking about it. And I can't set breakpoints in it because it's just compiled code. It'd be nice to, though. It'd be nice to bring all that Python stuff into this project. Did I forget something? Nope. It's all there. Well, it could just be there's something wrong with this function. Well, it couldn't be wrong with it. Yeah, I see the LED flashing on the thing, so it's sending the character. It's just not getting it. So it waits there because it's inside of this function. Once it gets a character, returns it into C, and then calls this function. But if there's an error, it breaks out. So it'd be good to see if it breaks out. So we're gonna use some good old-fashioned LEDs. Wait a minute, what am I doing? I got RTT. Can I use that with this? Yeah. Okay. Yeah, we're gonna throw RTT in this project for sure. I need to break open the. Let's see, where would I find some of that example code? I need some debugging stuff because I can't do breakpoints. So let's bring this over here. Oh wait, I don't have any gnome working on that board. Okay, that's not gonna work. We'll just do blinkies then.
Oh, they actually used the control on that, so I forgot about that. And it's not called. Now it's called BSPIO. Yeah. Okay. Let's do this. No. Okay. Now I need my delay function again. Oh. Okay. Basically, we're going to turn it on, wait a little bit, turn it back off. Actually, better idea is to do it in a loop. Okay. What language are I speaking? Blinkies. Oh, Blink. Yeah, RTT, real-time transfer. That's a J-Link specific protocol where it basically sends text across another port the same way I'm trying to do with this port, but it goes across the debug port. Oh. How entry. Oh, yeah, this. I think I've done this already once. BSP delayed, I see, yeah. Yeah, it's nice because it doesn't slow down the processor. It doesn't even use anything on the processor. It just uses the, well, no, that's not true. It uses some memory. And you have to put stuff in a buffer. Either way, I don't have it. Oh, okay, it's done. Let's see if it blinks. Because if it blinks, then it's failing this function. And if it doesn't blink, then I don't know what's going on. Yeah, time for some hype, huh? Whoop, whoop. I don't see any blinking. So that must be a good sign. Kind of. It's either getting stuck in here or let's do one more change. Let's do every time it gets a character, it should blink one time. And if it keeps blinking, then there's an error.
Yeah, it's not blinking. Now, there's the possibility it's getting stuck inside of that function. So we're going to make it blink before it gets to that function to see if I can get it to blink once. Because I feel like the UART's working. Because I seen that in the example project. It was working just fine. Wait a minute. I might not even be running that code. Because that event driven isn't defined. I forgot about that. I was looking at that earlier to see. I wonder what this pi exec friendly REPL is then. Because that might be what's being called. Yeah, no blinky. Okay, this code is not even being compiled in. So I need to figure out what this does. How am I going to figure that out? Google. Will exit when Control D is entered on a blank line. That doesn't help me any. That's just the code.
Hey.
I think I'm just going to go with the event driven. But then I need to probably define that everywhere too. Let's see. Maybe if I put it in here, we can see if it's at least calling this function. Because I know it's calling the tx function because I see the little character come out. But maybe they get mad when you hang up. No, because they want you to return a character, so that can be. Oh, I see it blink. Oh, that was just resetting. Okay, it just immediately turned on and back off. Okay, so it's calling that function. Let's see, Control D, Control C. No. All right, let's see if it's responding. At least see if it's receiving the character. Well, the thing that's going on in my while loop that I thought I was putting the LEDs flash is happening. It's just happening in the background. I can't edit that code. So basically this right here is doing the same thing that this loop is doing, or at least something similar. And I know it gets to here, at least, because I had the LED code before it. So now I want to see if it's receiving characters at least, because then it's whatever called. I'm going to have to debug that function. It could, I mean, who knows what they're, I could be, you know, I'm building with a new tool chain. No, same tool chain, just different MCU. Should work fine. Yeah, it's not receiving my characters. Interesting. So this isn't working. Wait a minute. It's opening it. Okay, let's try. Actually, let's just see. Nope. So it's not hitting the interrupt. What am I doing different on this? Alright, let's do something. Let's take my blank code.
And every time I send a character, I should get a blink. Yeah, it's working no problem on this project. Hmm. Yeah, it is already 6 something, ain't it? I probably need to eat. Ah. uh, it's sweet that you care so much about my mental fortitude at the moment. I'm completely dying. I know. I need it, but I must solve it. I have an unhealthy approach to this type of thing. And actually, I have been getting protein, by the way, and salt, which is really what your brain needs. Well, of course it's working, because the right works. That's the one thing I'm not doing in the other one, though. That's so weird.
Aha. That'll do it. I don't know why it didn't cause a build error. That will do it. The interrupts weren't enabled because there was no interrupt vector. Which explains why I was able to write. It just writes. It didn't. It gets interrupt after it's done writing, but you don't have to do anything with it. That built. Do I still have my reaction code? Yeah. Every time it gets a character, it'll blink. Yeah, I got 2 characters this time. Yep, I got a blink. Ah. Beautiful. Okay, get rid of the blank now. Speed things up. Okay. Do I need to get rid of anything out of here? We'll keep that loop. But we'll put it down here. After all their other code that they had. And if I get an error there. Okay. Rebuild it again. Hey. How's it going? I think I just got the basic, they call it REPL. It's basically the Python interface over UART for this. I don't even know. From what site? Wait. Yeah. Oh. Anyway. Ew, interesting. Okay. Ah, lovely. Ah, Control C actually works. Control D. That finished it. Okay, so Control D exits out. Control C. Okay. P. That was P. So the echo, something's not working right with the echo. Enter's working just fine.
Interesting. A? Nope. Is there something funny with my right? Because I don't normally, I'm not used to, let's see, Python doesn't usually have 3, does it? Let's see. Maybe it does. Yeah, it does. Okay, so that's actually normal. Let's see. Okay, so let's just glance at the right function, see if there's something silly. I don't control any of that. They just give me a pointer to a string and a length. So that tells me maybe I need to wait for it to be done sending? Let me see what the original one looked like again. They have way more UR code than they need. They don't even have the MP stuff in there. So let's see. This one they send one character at a time. They wait for it to be sent before they send the next character. But this one doesn't, and this is kind of how mine works. Well, just for the hell of it, I'm going to implement a simple wait. TX data empty. GTX complete equals true. Alright, so while not GTX complete. Okay. Oh, whoops. Oh, there's also TX complete. I wonder if I was supposed to use that. I can't remember. I think you get both TX data empty and TX complete. I think I want the TX complete one. Let's see. Oh, what is all that? Okay. Nope. That ain't it. Let's go down here. Put it here instead. Interesting. Alright, let's slow it down. Alright, and then I'm gonna reset this. It's getting to be a much faster workflow now that I got the main stuff out of the way. It's still kind of crappy compared to working inside of the IDE itself. But at least it'll be supported by their make system. Yeah, it still comes across funny. I wonder if they're doing... What would they be doing to cause that? No, I don't think it would be them that would be doing it. Am I using some weird settings here? Eight bits, none, 1 bit. 8-bit, none, 1 bit. Maybe there's just some problem with my cable here. Touching it, do anything? No? That's probably like the Python starting messages. It should say Micropython right here. MICROPYTHON, and then there's a space, and then there's like probably a V for the version number. But for some reason they're not coming across right. I bet you we're missing another included file. That's the only thing I can guess. Got HAL data, we got common data, got pin data, got vector data, got main. Header files are all included by RAGen right here. Let's see. Is there any other UART? Nope. It's all headers. You know, BSP clocks. I don't think that's in there, which would be weird if it... Okay, no it is. I'm going to sort these to make them easier to compare here. Clocks. Common. We don't have common. Delay. Group IRQ.
IO, RQ, register protection. Don't have ROM registers. How is this? I don't know. That could be something there. I don't know what the SBRK is, but I'm guessing it is. I don't have security. Okay. Pretty sure I have both of those. Out of order. But there. That's all includes. I already got all that. Recording it. I don't have the LEDs. Let's go ahead and add it. Maybe that, whatever it was missing, maybe that was it. Well, they definitely built them in. And the size went up a little bit, so something changed. I bet you there's some ROM registers that need to be set to get it to work right. Yeah. BSP ROM registers. File makes me think that anyway. No. That's FF, I think, or FE. Well, I guess I'm gonna take a break on this. Figure it out later. Good start though. Wow, I'm surprised. Let me go ahead and commit what I've done so far too. So added remaining files to makefile. Updated UART to 9600 testing. Added LED code for error handling. We don't need that. That's going to all go away. Updated UART RX code to wait for received character. Updated UART TX code to wait. Right. Complete. Love, bro. Have a good night. Yeah, I'm probably gonna eat something thick.